Hey everyone, let's take a look at number 13 in section 3.8. We're going to compute a derivative here of this function. This is this is the inverse sine or arcsine function, right? This is not the function 1 over sine of x, which is cosecant x, by the way, right? This is the inverse sine function. That -1 there is not a exponent, it's a superscript indicating we're looking at the inverse sine function. So we want to find the derivative of this function at the point x equal -3, 4, or when x is -3, 4 on the graph of the function. So you should recall from this section we talked about derive the derivative of the arcsine function here. It is equal to, amazingly, 1 divided by the square root of 1 minus x squared. No trig function or anything involved in its derivative. Very, very nice. Okay, so let's find the derivative of this function. Well, it's just 5 times this derivative, right? So it's going to be 5 over the square root of 1 minus x squared. They want us to now compute the derivative at the point -3/4. So I'm going to plug in x equal -3/4. So be a little careful with this. First square it, so be careful. Don't say a negative times a negative is a positive. You have to do the exponent before you do multiplication. So when I square -3/4, I get positive 9/16, right? -3 times -3 is positive 9. 4 times 4 is 16. So this will be 1 minus 9/16 under the radical. And then 1 minus 9/16, well, that's 7/16, right? You should be able to do that. 1 is 16/16, and then 16 minus 9 is 7. So the square root of 7/16 is the square root of 7 over the square root of 16, which is 4. And then dividing 5 by this fraction, I can multiply by the reciprocal of this fraction. 5 times 4 is 20, and so the final result is 20 over the square root of 7. This is acceptable. You could rationalize and write this as 20 root 7 over 7, but I'm fine with this answer here, and I think achieve is as well. And that's great. Hope this helps.